Yeah, good morning, everybody. I'm Volker. I'm from Nevada, working off of Berlin, and we do Android. And today I want to talk about the Android build system. So may I ask how many of you guys are and ladies are Android developers? So almost all, that's good. So as you then probably know, Android has a shiny new build system. It's been released not long ago, actually in December last year. It's been around for a bit longer since Google has announced it already 2013, I think, and then preview versions have been around for quite a while. So, and not only is the build system completely new, also the tooling around it, so the IDE has changed. It's now Android Studio. And what it features is a deep integration with the build tool. So now whether you run from your IDE or from the command line, it doesn't matter anymore. It's the same build steps that get executed. Okay, so to make that a bit more entertaining here, I try to take you on a journey of a young entrepreneur into Android land. And I want to make that a bit more realistic, I hope, by increasing my hipster level by 1. So let me take these glasses here, and let's all take a sip out of the hipster ale can here, and then let's get started. So hi, I'm Volker. I have an idea for a great app that's going to change the world. Yeah, and I've heard a few good things about Android lately. So I want to try it on Android first. So there are a lot of activations. Almost 1 billion Android devices have been activated by now. They are on phones, they are on tablets, right? They have entry-level devices, they have high-end devices, they are in emerging markets. They even run on TVs and phones these days, so seems like a safe bet. And what I've heard, they have new tools, and I'd like to try them out. I know some of the Java stuff. So let's download Android Studio, open the new project with it, and see what we get from that. And let's look at the build side of things. The first stop probably is the build.gradle file you find in the app subfolder. Yes, why is it called build.gradle? Because the new Android build system is based on Gradle, the build tool. That's great because Gradle has been around for 10 years. It's a proven platform, proven build system. It's scalable, it's extendable, and it can handle really big builds. And now we have it on Android, which is great. So the first line you see over there is that we apply the Android plugin. So the Android build system is just a plugin into the Gradle build system. And what that gives us is a language to describe our Android projects. So in this Android block that follows here, we just specify what our project is all about. So the SDK we want to compile against and many other things, what tools to use. And down here we can also specify different types of our builds. So in this case, we specify a release version to build. So there's always a debug version. And we specify a release version here as well. And then we can define our dependencies down there. So what's interesting maybe about this script is that we don't define any actions of our build here. So we just declare what we have, and then the build system makes sense of that and gives us some actions that we can then execute. So this is nice. And although that looks like and it is actually a domain-specific language, what it comes down to in Gradle is just Groovy code. So the Gradle build scripts are run as just Groovy scripts, so we can make use of all the niceties that the Groovy language gives us. And yeah, we'll see some of that later. Actually, there are some more files relevant for the build. So we've seen the first one here in the app subfolder, the build.gradle, but there's another build.gradle in the root folder. Then there's a Gradle subfolder with some wrapper subfolder in it. And then there are some properties files, the settings.gradle, and there's 2 files called Gradle-w, that's the Gradle wrapper. It's 2 scripts, one shell script, one Windows script. And these scripts make sure that you always run against the same version of Gradle when you run your build. So this is nice. We have more reliable builds due to that facility here. So we just run the wrapper. It makes sure the specified version here in the Gradle wrapper properties gets downloaded. And then we run our build always against the fixed version of Gradle. So more stable, more reliable builds. And let's look at the whole layout here again. What this tells you, if you are into Gradle a bit, is that you have a Gradle multi-project build here. Actually, there is only one sub-project in the app subfolder, but the layout here is prepared to handle more than just one sub-project. So it's a Gradle multi-project build. Okay, so what can we do with that build? That would be the next question, right? So we ask Gradle, what actions can we execute on that build here? And we do that, the actions in Gradle are called tasks. So we just run the wrapper like this and ask what tasks are executable now. And you see there's a lot of stuff we can do with that build here. So there are install tasks, test tasks, compile tasks, whatnot. And you see quite often there's a debug and a release version. That's actually the build type that comes in here already. So we have always a debug build type, and we've specified a release build type. So we have versions for these types. And yeah, you see that would be a lot of typing here if we would have to type all these tasks, a lot of keystrokes. But fortunately, Gradle supports camel case abbreviations, much like your IDE would do. So tries to resolve as soon as possible. So you can, for instance, instead of running connected Android test, you can just write con capital A capital T, and then Gradle makes sense of that. And also you can put more than one commands on the command line. But still, this Gradle wrapper looks a bit ugly, especially since it has a reference to the current directory. So if I'm in a subdirectory, want to run my Gradle build, I have to be aware where I am and have to specify the relative location to that wrapper script. But there's a little tool we can pull in. It's called GDub, and it provides us with a little script. And then instead of writing this ./gradlew, we can just write GW, and it even works in subdirectories, right? That's what I wanted to say. Yeah, nice abbreviations here, so Gradle makes sense of that. And looking at the task again, you see, we've a lot of stuff, but there is no run tasks actually. That's a bit odd, because if we run from inside Android Studio, there's just a button. If you have a device connected or an emulator running, we just press the button, and then the application gets started on the emulator or device. And that seems not to be supported out of the box by Gradle. So there is no run task, but Gradle is extensible. So let's extend it for that. So we want a run task. So there's the first plugin, Gradle plugin we can pull in. In this case, it's the Android command plugin. To integrate that, we have to first in the root build.gradle, we have to declare dependency on the jar file that contains the plugin, and then in our app build.gradle we can just apply the plugin, much like we applied the Android plugin. And then there are even more tasks. For instance, now there is a run debug task, and that installs the application and runs it right away. Okay, problem solved. Now we want to start develop, right? We have this great idea, and of course, we want to focus on our idea and not on all the solved problems around that. So we want to rely on all the great libraries that are out there. For instance, here in this case, we pull in Guava, and Gradle makes it quite easy because it has first-class dependency management. You can depend on any libraries, on any Maven or Ivy repositories. And Gradle has a concept of dependency configurations. There are predefined ones like this here, compile and test compile. That just means your application needs this library at compile time. Also, it has to be then there at runtime, of course, and or here at test time, test compile. But sometimes you have more involved dependencies. For instance, if you want to use annotation processing libraries, like Dagger, for instance, and then you need a bit more. because the annotation processing compiler, like the Dagger compiler dependency over there, is actually only needed at the annotation processor class path, right? So there's a special property at Java-C, and at that path you would put the compiler so that it's not visible in your regular class path. And there's only limited support for that in the Android build system. So there's a provided scope and there's a package scope, I think. But still, if you don't want it on your compile class path, then you can pull in another plugin, and it's called the Android APT plugin. You apply it the same way we've seen earlier. And then what you get is a new dependency configuration called APT. And then you can make use of compiler or other, of the Dagger compiler here, or can use other annotation processing libraries like AutoValue and whatnot. There are many more. Also, I mentioned build types already, but the build system also has the concept of product flavors. That means you can build little differing versions of your project. So you can, for instance, define a free version and a paid version, and these versions can then differ in functionality a little, for instance. So it's basically the same code base, but some differing branches, and then you can add some dependencies just for the paid version. Like in this case, we may have a dependency to some license verification service, or for a free version, we might have another dependency for maybe an ad showing a library or whatnot. So Gradle makes it easy here to pull in these specific libraries just for the specific versions here. Okay, so we've pulled in a lot of libraries, we've been busy developing, and now our application shapes up nicely, so we're almost ready to deploy it. But there's one point to consider. So who of you has seen a screen like this before? I guess quite a few people here, yeah? So especially with entry-level devices, still a problem, so make sure that you only ship stuff that's actually needed in your application. So many of these applications have become quite big over time. So it's quite easy to do it. There's only two flags you have to switch on for your release build. There's minify enabled and shrink resources. So uses the ProGuard tool to strip out all the code and resources that you don't need. But be careful, especially with third-party libraries. There are some considerations because these libraries are quite specific on what they want to keep in over the ProGuard step. So, but there are good tools out there to give you hints of how your ProGuard configurations for the libraries should look like. There's, for instance, a library called Squad Leader that also gives you a keep annotation. So you can just annotate your code, and it's kept by ProGuard. And they also ship some, for the biggest libraries, they ship some of these configurations. So you just depend on that library, and then these, the biggest of the libraries work out of the box. But there's a lot more information on that for other libraries as well. So start doing that early, and of course test your release builds, not only your debug builds, to make sure that ProGuard didn't break anything. Okay, so the first iteration is done. We have a prototype or a first version of our great idea. So we want to deploy it to the App Store. So we create a account. We upload the APK. We have to do provide a lot of description, screenshots, whatnot, even a video I think we could provide. Yeah, done, uploaded. And now, of course, we also want to have some basic archiving functionality here. So it's time for a first custom task. Gradle makes it easy to create your own tasks here. In this case, we just define an archive release task. It's of type copy. And we just configure it in this, what's called a Groovy closure, so in this block here. And we just say what to copy and where, and then we can even rename it on the way. And what you see here is that we make use of what's called extra properties in Gradle. So you can define, even in your root build script, you can define some properties like this up there. And then you can use them in your build script like any constants. And Groovy also has this nice facility of what's called Groovy script, so it can inline resolve the properties inside of a string, so you don't have to do any string concatenation as you would have in Java. You can just write it like this. Okay, great, archived. So the first iteration is done. We have come up with a basic, or with the first version of our great idea. It's in the store now. And what you've seen here, if you want to go deeper on this, on working with Gradle on Android, then there's a good course here. It's at Udacity. And I'd recommend you watch it. Yeah, it's quite good. And it's about 3 hours worth of Gradle goodness. So please watch it. So what happens to our app now? So we get lots of downloads. People are euphoric about our app. So all is great, right? And we get a lot of feature requests. And maybe we can even get some funding now for our great idea. We've proven that it works, you know. So now it's really a product. So we have to scale up development and make it more sustainable, right? So what are the pain points we currently might have? Of course, there's only one module. We only have the Android module. So there's no way to reuse any of that code. So we might try look at that. Then we hopefully have written some tests, but there's no test automation. We don't have any continuous integration server running. There's no static code analysis running. Now, where we are growing, we are building a team, so we have to focus on that stuff as well. And once we have that CI server, then we also would like to release from the CI server by just pushing the release button, right? So let's scale things up. First, let's look at reusable code. So Gradle makes it quite easy to separate our domain-specific code from the Android-specific code. So we can just run this one-line command and create a pure Java module. So now our multi-project build has 2 sub-projects, a pure Java project and the Android project. In this case, I called it model here. And of course, now we move over all the domain-specific logic into the pure Java module. And then, of course, our Android project depends on the model project here. So that's what I pointed out here. And while we're at it, why not add a Groovy module as well? So it's as easy as this line down there. So, and this is nice for playing around with APIs and domain modeling or testing some backend stuff. So Groovy really makes it easy to do some explorative scripting. For instance, here with these 3 lines I put down here, you can consume some JSON API. So it's nice, dense code, and yeah, it's great for exploring API endpoints or your models. Yeah, what's next? Testing. In your Android modules, you probably know that there you have a test folder and you have the Android test folder. And in the Android tests, you run your connected device test, and your plain JUnit test you run are living in the test folder, right? And we would like to have the same separation between our integration and our JUnit test in the core module now. And actually, it's quite easy to do that with Gradle because Gradle has a concept of source sets. Test and main are predefined, so we define another one. It's called integration test in this case. So we just tell it where to find the sources and resources, and then we can define a custom task again. This time it's of type test. And now we can run our integration test via this integration test task and the normal regular JUnit tests via the regular test task. So great. Same separation over there. Now, okay, I mentioned we have a lot of dependencies, right? So we rely on a lot of libraries, and you know these the version change all the time, and we have to keep track of that. And there's a nice little plugin you can use for that. It's called the Gradle versions plugin. You apply it again, and it gives you another task called dependency updates, and you run that task and gives you a report about the latest versions of your dependencies. It's quite nice because then you can be aware of the latest things and update or make an informed decision on that at least. Next, code quality. We would like to run static analysis tools, right? So the usual toolings are checkstyle, find bugs, PMD, and all this is supported out of the box by Gradle, which is good. It works nicely in your Java module, but in Android it doesn't quite work. So because the Android plugin is not, at least in the moment, not fully compatible with the Java plugin. But what you can do, you can reuse the task type that is provided by the checkstyle plugin, in this case here, for instance. So you have to define your own custom task around that, but this can be based on the checkstyle task. So you do the configuration here manually and create a checkstyle main task in this case. And since we have to do that, we can even tweak it a little bit. So in this case, we have added some property here. It's a project property called fail fast on error. And this allows you to specify some command line properties like down there via the -p option. And then you can act on that inside your build script. So for instance, in this case, if I run locally, I would like to fail on the first checkstyle error because I'm in fixing mode. So fail on that one, I want to look at that. But if you run in some automated environment, then you would rather not fail on the first error. You would like to have a full report of all the issues you have, so you don't want to fail fast, right? And you can easily achieve that with properties like this one over there. And also what checkstyle gives us by default is only an XML report, so we would like to have an HTML one, at least if we ask for it via another -p property over there. And it's easy to do so. So we can just add some custom logic via the do last block here. So we specify some code that should run after the checkstyle task has been run, or as a last step inside the checkstyle task we define here. And in this case, we just execute an XSL transformation to transform the XML output into some HTML for better readability. And what's nice here is that we can make use of AND targets as well, because Gradle comes with full AND support. So we can reuse all the AND knowledge, and yeah, we don't even have to use XML for that anymore. We can use nice dense Groovy for that. Okay, great. So yeah, we have the tooling in place, but we would like to run it in an automated fashion, right? So we need some continuous integration server. So Jenkins is, I guess, the default here. So let's install a Jenkins server, and now we would like to distinguish between a local build or a build on Jenkins, and it's actually quite easy to do so because these servers usually specify some environment variables. Jenkins, for instance, has a property called build number, and we can read that build number and then make sense of it, and we can even use it in the version name of the artifacts we built. So that gives us a nice one-to-one mapping between the Jenkins job that builds some artifact and the APK we have on our device. So this is nice. Yeah. So all is good. We have Jenkins in place. We can run our build automatically, but now we run into issues whenever we update the Android SDK. That's usually what you do manually, right? Or do you update it automatically already? Actually, there's a plugin for that. It's called the Android SDK Manager, and that does exactly that. So if the SDK is not up to date and doesn't fit to what you need in your build, then it just downloads the missing parts, and yeah, all is good. Problem solved. Great. So now we can really run on the CI. And of course, we also have connected device tests that now run on the CI. So we connect devices to our CI server. And what you find there is that the tests are run on every device that's connected. So, and if we want to limit that to a certain subset, then we are on our own currently. So it's not supported by the Android build system, at least for now. I don't know, maybe they change it later. But that doesn't mean we cannot make it work, because we have some additional weapons under our belt here, because we can make use of Groovy meta programming, and that means we can just override methods of the implementation of the Android build system. Actually, in this case, we find the connected device provider that via the get devices method returns all the connected devices, and we just override that method and add additional filtering here. So what we filter out is we don't want to run on tablets in this example here, so we try to find a property that indicates that the device is a tablet, and if it is, then we just exclude it. And worth noting, there is the use of the question mark dot here, and this is called the safe navigation operator in Groovy. And that means if the left side is null, then this operation just returns null. Otherwise, it would throw a null pointer exception, right? So nice, clean logic over there. And then in the last line here, we specify, okay, we only want one test device per API level to test, okay, just to make it a bit more less bloated. Okay, this is the custom task. We have defined it. And what's interesting here is that this task doesn't have any type, so it doesn't extend any task type. Instead, it has these lesser, so what is it, shift left operator syntax, and this is the same as saying do last. So this is really an action we give to the task. So when the task is executed, then please execute this code here. So there's no configuration, which would be defined by just opening the closure, right? So there's the task now, and now we have to hook it into the build lifecycle, and we can do that by just asking for all the tasks that are related to the device tests. And then we say for each of them, please, before you run the filter test devices tasks. And there's another nice Groovy operator here, the star dot. It's called the spread dot operator. And that acts on a list and just executes the method after it on each item of that list. So again, clean, nice syntax. Yeah, and why do we put all that stuff into that after evaluate closure here? It's because the task might not be there up front, right? So Groovy in the first phase of the build execution, it has to make sense of all the task specifications, and we say, okay, only if you have discovered all the tasks, then call us back here, please, and then we want to act on the list of available tasks. Okay, great. That's worked. And finally, we want to release from the CI. So we want that push button here. And what's missing for that, to achieve that? First, we would need some automated version updating, right? So some tasks that just updates our version. Then once we have that, we would like to push the new version back to our CI system, back to our repository, And then finally, of course, we want to upload to the Play Store in an automatic fashion. So let's look at versioning first. Suppose we have a custom class here that enforces our versioning scheme. It's called version. And then we just externalize the properties that are related to versioning, like maybe version number, version name, whatnot, major, minor version numbers into some properties file. And then our custom class version reads in that properties file and can increment the version according to our defined version scheme. And then we can just create a custom task. In this case, it's called increment version. And this custom task then increments the version for us. But what's it with this custom class version here? Where does it live? And actually, Gradle has the concept of a build source folder. And there can be a regular project under the build source folder. And this project gets built before your build is run. And then all the artifacts that are built inside that are put onto your build class path. So it's perfect for putting custom logic in there. So we just put the version.groovy class in there, and that can handle our version increments. Wait a sec. Yeah. So now we have incremented the version. Would like to push that back into our repository, right? So we need some Git support in our build. So it's easy to do. We just pull in a library that does it, gives us some Groovy syntax to work with Git, and internally it uses a JGit library from the Eclipse Foundation. Yeah, and once we have that, we make use of the extra properties here again that Gradle provides, define a Git instance, and then we can do add, commit, can even define a nice commit message, and then push it back into our repository, so solved. And finally, we want to release to the Google Play Store in an automated fashion, and yeah, it's easy to do. Another plugin, it's called the PlayPublish plugin. We apply it, and this gives us these publish tasks I've listed here, and it even allows you to work on the like screenshots and descriptions offline, and then it pushes all that stuff to the Google Play Store. It needs a little setup, you know, it has to make sure that you really own the account you push to. But yeah, then it works quite nicely. Okay, so great, a lot of automation now, and yeah, I hope I could show you how you can really make this a more sustainable development. And how much time do we have left? 20 minutes. Okay, that's good. Now I have some more little tips and tricks. So maybe we just have a look at some more of the problems you might run into. One is of course shared build logic, right? So we have 3 modules now. We might have even more once we start doing web development. Can also be done with Gradle quite nicely. And we want to share common configuration. For instance, as you've seen, we have check style and find bugs in place. So we have the configuration files, and they are now used in the Android module and in the core module. So we would like to share them. And you can just define a method like up there in your root build script, and that can decouple the physical location of the configuration from the actual usage. So in the usage, and for instance in the app module, you would just say rules and then give it some relative path, and that would allow you to swap these configurations. So if you want to have more advanced rules in some situations, you can just swap that, and you wouldn't have to change your projects for that. Only the root build script would have to change, right? So another way to share build logic, yeah, what is that? Okay, you have probably the same library dependencies in different projects, and again, just can use the extra properties in the root build script, define the dependencies, and then you can even nicely group them into lists. For instance, here with the testing libs, you can say, okay, I always use JUnit and I use assert J for testing. And then you just group it like this, and then down here when you use it, you just say, okay, my test compile dependency configuration uses the testing libs. Yeah, now some more Android-specific configuration here. So I guess you guys are familiar with the build config field logic here. So the Android build system configurates or generates a class called build config for you, and there are constants in there. So traditionally there was only a debug release field. Nowadays they put in some more stuff, and you can configure your build script to put even more configuration constants in that class. And you just do that via the build config field method up there. So you can just define, okay, I need a tag for whatever, maybe for logging or something else. And then you define what it should be, and you define it for the debug and for the release version in this case. But you see there's quite a bit of duplication, because, okay, it's a string, yeah, it's going to be a string in the debug and in the release build, because, yeah, I rely on that. And also it's on the name, of course, that's not going to change between the two definitions as well. So, and you can get rid of this duplication by defining a custom method now inside your build types. You just specify, okay, for all my build types, I want an extra method like this one. And I call it tag because, yeah, it specifies a tag. and that should just call this build config field with type string, name tag, and then just add the tag I specify, and then I can abbreviate the configuration like this down here, so it's a bit nicer. And it's even more interesting if you have more than one of these properties that kind of belong together, like for, I don't know, analytics configurations and server configurations or whatnot. Library shrinking, yeah. How many of you have had issues with this 64K DEX method limit? Yeah, it's quite common nowadays. I mean, all these big libraries, right? So, and if you run into that only in your debug build, which happens usually first because ProGuard doesn't run on that, then you might consider stripping down your the libraries you depend on, and you can do that manually by just using ProGuard directly. ProGuard comes with a Gradle task, so you can depend on that. And in this case, I just shrink Guava to only the package common base. I don't know if that makes too much sense. So then, because you lose all the collection goodness, but it's only 200K then, and you can use some of the basic niceties that Guava gives you. But even with the collection libraries, it's quite a bit more slim than the full version. So that might help you to avoid the hitting the 64K method limit. Yeah. Okay. Yeah. One more thing I wanted to mention here is that there's also a nice little Gradle plugin you might apply. It's called the DEX count plugin or something. And whenever you run an assemble task, then it gives you a little output about the number of your methods you currently have. So it makes you aware of your method count. Next thing, yeah, this relies on the command plugin I've mentioned earlier. So maybe you have an application where you always have a login screen as a first screen. It can be quite annoying in development, and the command plugin allows you some basic automation. Basically, it's a wrapper around the ADB tool, and ADB can, just fake some input. So if you have an login screen like this, then you can just script it and run this task, and that gets over the login screen, right? Just pretending to be a user here. Also, with the command plugin, you can sync your file systems on the device and on your development machine. In this case, I just sync my photos here on my Moto G. But it can also be useful for setting up some text fixtures, for instance. If you have some file-heavy application, then it might make sense to set up some configurations to test then on. So this is quite handy, and of course it allows you all these nice little groovy filtering mechanisms. Yeah, working with SQLite databases. Who's using SQLite? Okay, so quite a few. So with the database, you always have usually two sources of truth. You have the database and its schema, and then you have to know about that schema in your Java code. So there are tools that take care of that. So if you just specify your database from your Java code, then there are tools that can generate the database for you. But if you have an existing database, for instance, then you cannot do that. So you need some other tools, and there's one. It's called the SQLite Analyzer, and what that gives you is it takes an SQLite database, analyzes it, and generates a model from its schema, and then gives you that model and generates the Java access code from that model. So it's kind of database first approach, and the Java access code is generated. And what's nice about it is that you can generate whatever you want. So there are some defaults, some default codes that get generated. But if you have some specific needs, like for instance, maybe you are only interested in the table names for some weird reason, I don't know why you would, but maybe you are, then you can just specify your own template here. It's just a Groovy template, and gets injected the model, and you can easily generate the code you want, right? So if you just want some light abstraction on top of the cursor that Android gives you, can do it. If you want some full object modeling on top of that, you can do that. So it's quite easy to customize. And what's nice about the implementation is that the plugin hooks into the build lifecycle that the Android plugin provides. So you can tell the Android plugin, hey, I have a task here, and this task generates code, and please execute it at the right point in time for me, and make all the generated code visible in the IDE. So this is quite handy. Also, the APT plugin does it like that. Yeah. And last suggestion here, you can also use Groovy in your Android application. So there's the Android Groovy plugin. And yeah, you have to apply it. Yeah, we've seen that before. And then you just depend on some specific version of Groovy here, down here. And then you can write your application in Groovy. And it's not only a proof of concept, it actually seems to work quite well, because at least the New York Times application does it and has a blog post about it and seems to be quite happy with that decision still. So there's not only Kotlin if you want to try alternatives. You might also have a look at Groovy. Yeah, and that's all I have. Thank you. Yeah, so we have this. Did anybody use the website, or are we just asking questions? Are there any questions this early in the morning? Yeah.
So you have a lot of plugins, right? How does that affect the length it takes, the time it takes to do the configuration for the Gradle? Because that's usually very, very huge chunk of Gradle build.
Yeah. So the question is how much a lot of plugins affect the build time. So actually, we haven't measured that yet, but it doesn't seem to be a big issue actually. Of course, it might depend on the plugin you apply, right? So if there's a lot of upfront logic in that plugin application, then it might be an issue. But yeah, it hasn't been for us currently. Sorry, I didn't get that.
Basically, do you have possibility in Groovy to store secure data credentials, or
Okay. So the question was if it's possible to store any secure credentials and in Gradle, yeah. And I haven't heard of anything like that yet. Yeah. Yeah. Any more questions? Then thanks for showing up that early and enjoy the conference.